The point with coordinates is a is 0 is on the line with the equation y is equal to x plus 8. What is the value of a? Substitute it into there, so that would mean that 0 goes for y and a goes for x. So that means a would be equal to negative 8. If x is equal to this big long thing, what is the value of x? So let's do the fractions. This is going to be 11 over 12, and then it's going to be 10 over 11. Then this one will be 9 over 10. Then the next one is 8 over 9, and so on, right? And the last couple will be 2 over 3 and 1 over 2. And they're all being multiplied by each other. So you'll notice like this cancels with that, that cancels with that, that 9 will cancel with that, that will eventually cancel with that. That will cancel with the 2 will cancel with that 2. So the only thing we'll be left with at the end is this 1 over 12. And that is the value of x. In the diagram, a large rectangle is divided into 5 smaller rectangles, which are labeled A, B, C, D, E. In how many ways can exactly 2 of these 5 rectangles be shaded so that the shaded rectangles are not touching? Okay, so let's talk about this. A can be paired with C, and A can be paired with E, and that's it, because the other ones are touching. B, let's see here. Well, B can't be paired with anything, because everything it's touching, so we want not touching. C can be paired with A, C can be paired with D. D can be paired only with C, and E can be paired only with A. But think about it. Even though we have listed all of these, some of these are the same. So AE, for example, is the same as EA. CD is the same as DC. And CA is the same as AC. So the only unique ones, I guess these 3, you can call them unique. So 3 is the answer to this question. The length of a diagonal of a square is 10. What is the area of the square? So let's just draw a square. And then the diagonal, they're saying, is 10. Now the square has sides of x and x. So using Pythagoras, x squared, because this is a right angle, plus x squared is 10 squared. So 2x squared is equal to 100. And therefore x squared is equal to 50. And they want, what do they want? The area of the square. The area of the square is equal to x squared. And we just calculated it as 50. So that's the answer. A 3-digit positive integer, n has digits a, b, c. That is, a is the hundredths digit of n, b is the tens digit of n, and c is the ones digit of n. Determine the largest possible value of n for which a is divisible by 2. The 2-digit integer ab is divisible by 3 but not by 6, and n is divisible by 5 but is not by 7. So let's take this one step at a time. A is divisible by 2 basically means that a is an even number. So a is even. So that takes care of that. The 2-digit AB is divisible by 3 but not by 6. So it's multiples of 3 but not multiples of 6. So we're going to write them all out here. We have 3, 9, 15, 21, 27, 33, 39, 45, 51, 57, 63, 69, 75, 81, 87, 93, and 99. So these are basically numbers that AB could be, because they're all divisible by 3, but they're not multiples of 6. And then this last criteria, n is divisible by 5, but not by 7. Okay, divisible by 5, but not by 7. Okay, before I get to that, let's just circle the ones here that we can use. So A has to be even, and AB has to be 2 digits. So that eliminates 3 and 9. A has to be even. So this one, that one, 45, 63, 69, 81, and 87. Those are the only ones that would match both of these criteria. Now let's get to the third criteria. N is divisible by 5, but not by 7. So if a number is divisible by 5, that means its last digit would be either 0 or 5. So we have to make n with these guys. So we have to make a 210, a 215. You see what I'm saying? Yeah. And then 270, a 275, a 450, of 455, and so on. You guys get the point. 630, 635, 690, 695. What's the next one? 810, 815, and finally 870 and 875. Okay, so that takes care of this part, the divisible by 5, but not divisible by 7. So we've got to get rid of the ones that are divisible by 7. This is divisible by 7, so I get rid of that one. So is this, and so is this, and so is this. So the only ones that are left are the ones that I didn't cross out, and they want the largest of those, and the largest of those is 870. Determine all pairs of real numbers xy for which 4x squared minus y squared all squared plus 7x plus 3y minus 39 all squared is 0. So this is squared and this is squared. So that means that this is either positive or greater than 0, this whole thing. And this whole thing is either positive or greater than 0. That's the only way it can equal 0. If something is squared, it's going to be positive, or it could be equal to 0. But since this plus that equals 0, both of them have to be 0. So that means that 4x squared minus y squared is 0. And it also means that 7x plus 3y minus 39 is equal to 0. That's the only way that this equation could ever work. Okay, so let's do this. So this one would be 4x squared is y squared. So if you take the square root of both sides, it would be 2x is equal to plus or minus y. So that means y is either equal to 2x or y is equal to minus 2x. So these are our two options, and let's see what we get. So let's plug in the first one to this equation. This y equals 2x. So we would get 7x plus 3 times 2x minus 39 is 0. So solving for that, we get 13x is equal to 39, so x is 3, and therefore y would be 2x, which is 6. So that's our first pair, 3, 6. Okay, now they want all pairs, so we've got to take this guy into consideration, the y equals minus 2x. When you sub that in, you get 7x plus 3 times minus 2x is equal to 39. So that would mean x is equal to 39, and therefore y would be minus 2x, so minus 2 times 39, which is minus 78. So our second pair is 39 and minus 78. So there you go. Those are the two pairs. An arithmetic sequence has a common difference, d, that is, a positive integer and greater than 1. The sequence includes the three terms 3, 468, and 218. 2018. What is the sum of all the possible values of d? Okay. Well, they just told me 3 terms. Okay, they didn't tell me which 3 terms. So I have no idea. It's a plus something d is 3. And then a plus something d is equal to 468. And then a plus something d is equal to 2018. And that's all we know. Well, I can take these two guys and subtract them from each other. So if I do, I will get 468 minus 3 on this side. And on this side, we would get yd minus xd, and the a's would cancel. So if you factor out the d, it would be x minus y is equal to 465. So that means that d is a divisor of 465, right? Yeah, because d is equal to 465 divided by x minus y, and x and y are both integers. All right, so the same story. Let's do those two. So it'll be 2018 minus 468, and that would basically be the same thing. Z minus y times d. So d would be equal to 1550 over z minus y. So that means that d is a divisor of 1550. So those are the two pieces of information that we can conclude. So since it's a divisor of both 465 and 1550, we've got to find the common divisors. Okay, so what is 465? First of all, it's 3 times 5 times 31. And what's 1550? It's 2 times 5 squared times 31. So the common divisors would be 5, 31, and 5 times 31, which is 155. So the sum of those divisors would be 5 plus 31 plus 155, which is equal to 191. There you go. Rectangular room ABCD has mirrors on the walls AB and DC. A laser is placed at B. It is aimed at E, and then the beam reflects off the mirrors at E, F, and G, arriving at H. The laws of physics tell us that BEC is equal to FEG, BFE is equal to AFG, FGE is equal to HGD. If AB is 18, BC is 10, and HD is 6, what is the total length of path BEFGH traveled by the laser beam? Okay, well, we gotta first draw in some lines here. Let's see. The first one I'll draw from G all the way up to the top. Alright, so then what that does is helps us a little bit, I think, because we can use the fact that a lot of these I think are going to be similar. For example, because they've given us these angles, right? BEC is equal to FEG, right? And they've given us that BFE, this angle in here, is equal to AFG, that angle in there. And then FGE, we can call it beta, is equal to HGD, so this beta. So what that does is helps us a little bit. With similar triangles, we can, because this is a right angle, because I drew them so that they'd be parallel to the sides, and this is also a right angle. Then basically we have a situation that the angles are going to be the same, meaning they have similar triangles. So let's label the sides AB. This whole thing is 18 all the way from A to B. BC, that whole thing is 10, and then this little guy HD is 6. Okay, so 10, let's see here. D to G, I'll just call that A. And this E to C, I'll call X. Now, I need to figure out how to label from here to here, and then from here to here. Now, that's going to take sort of an understanding of what are the angles here. Let me think about this. Well, let's see here. If you do angle chasing, and it's pretty straightforward to do through these angles, you'll find that this alpha is actually equal to theta, and the beta is also equal to theta. And what that essentially means is that these are all the same kind of triangles, and therefore this guy is X and that is X. So I'll let you do the angle chasing. That's fairly straightforward, not that difficult to do, and I'm sure you can do it. So now we can use similar triangles on this guy right here, HDG, and this triangle BEC. And that is that 10 over X is equal to 6 over A. And that basically means that A is equal to 3 over 5X. So now we add up these guys. We've got A plus 3X, and that is equal to 18. It's the same as up there. And then A is equal to 3 over 5X. So that would mean 3 over 5X plus 3X is equal to 18. So 18 over 5X is equal to 18, so X is 5. And therefore, what are we trying to figure out here? Oh, the total length of the path. Okay, so I've got to first figure out what is BE. And we can do that with Pythagoras, pretty straightforward, 10 squared plus 5 squared. So BE will be root 125. And the exact same story holds true for FE and FG. There will also be root 125. And then HG, the final piece of the puzzle, is 6 squared plus 3 squared. Hold on, let me see here. DG is equal to, 3. So HG squared, that means HG would be equal to root 45. So then to get this BEFGH, you have to add them all up. So it'd be 3 of those 125 roots plus the root 45. And I guess if you combine them and all that, it'll be 18 root 5. A box contains R red balls, B blue balls, and no other balls. One ball is removed and set aside, and then a second ball is removed. On each draw, each ball in the box is equally likely to be removed. The probability that both of these balls are red is 2 over 7. The probability that exactly one of these balls is red is 1.5. Determine the pair RB. What they're asking for is how many of the balls are red and how many of the balls are blue in this particular box. So we are given a couple of pieces. Probability that you get R and then R. Let's see, that is 2 over 7. So that's when both are. The probability that you get an R and then a B, so that means exactly one is red, is 1/2. Okay, so initially in the box you have R balls and R red balls and B blue balls. So the total is R plus B. And then after you draw one ball, you will have R plus B minus 1 balls remaining. So the total ways of getting, I guess, 2 balls is R plus B times R plus B minus 1. Total ways of drawing 2 of the balls. Okay, so then to draw, let me think about it. So that's the total. Now, if we want to draw, say, 2 red, you would draw the first ball, you have R possibilities, and for the second ball, you have R minus 1 possibilities. So this 2 over 7 really is calculated as follows. It would be R times R minus 1 all over the total, which is R plus B times R plus B minus 1. Got it? Okay, so we'll call that equation 1. And then in a very similar way, this 1 over 1/2, well, the denominator is going to be the total, so we put that in there, R plus B minus 1, and that'll be equation 2. But the numerator is a little bit, not tricky, but to get exactly one ball, you could have an R and then a B, or you could have a B and then an R. So you have R choices for the first ball, and then you have B choices for the second ball. But you could have also have been the blue ball was first, so B choices for the first ball, and then R choices for the second ball. So that's the setup for that half. And then now our job, since we have 2 equations and 2 variables, our job is to solve for R and solve for B. So let's do that. And I will do that by, let's see here, if I take equation 1 and divide by equation 2, then what I'll get is R times R minus 1 over 2R times B, and it'll be 4 over 7. So no tricks there. I just divided equation 1 by equation 2. And then now I can, in a very straightforward way, kind of solve this. This will be, let's see, well, the R's cancel, so it'll be just R minus 1 over B, and that'll be 8 over 7, I believe. And then if you cross multiply, you get 7R minus 7 is 8B. Or R is going to be 8 over 7B. Hold on. Let's see if I did this right here. r will be 8 over 7 plus 1. Yeah. Okay. And then I subbed it back. So sub this guy, sub into any of those, 1 or 2. We can sub it into 1, let's say, or sub it into 2. Doesn't really matter. And when you do, so you sub it back into here and then solve. And I'll let you do that. When you solve, you'll get b equal to 91 and r equal to 105. So the r, what are they asking for? The RB is 105 and 91. A cylindrical tank has radius 10 and length 30. The tank is lying on its side on a flat surface and is filled with water to a depth of 5 meters. Water is added to the tank and the depth of water increases from 5 to 10 plus 5 root 2. If the water volume added to the tank in meters cubed can be written in the form a pi plus b plus c root p for some integers a, b, c, and prime number p. Determine the quadruple ABCP. All right, so let's establish a few things. The volume is pi r squared times height. And in this case, the radius is 10 and the height, which they are pretty much referring as a length, is 30. And then therefore, the total volume, if the cylinder was completely full, would be pi times 10 squared times 30. And that is 3,000 pi. So we're going to be using ratios here. Yeah. Okay, so let's talk about this. Let me draw a circle here. And let's talk about how you would actually approach this question. So let me first draw an attempt at what I believe is 5 meters. So let's say from top to bottom, let's say this is the center. So this is 5 right here. And actually, I think it would, if this is the center, and that's, the radius is 10, right? So I think 5 would be up to here. Yeah, because then that would make a little bit more sense. Not perfectly drawn to scale, that's 5, but that's pretty close. Okay, so this is all water, let's say. Now we have to figure out what is the area of that, and then we can talk about volume. Okay, how do we do that? Well, what I'm going to do is show you how. Draw 2 lines here, one going from here to here, and one going from there to there. And therefore, that sector will help us out, and I'll explain. So first, we've got to figure out the area of the entire thing. That would be pi r squared, so that's 100 pi, since r is 10. And then I'm going to introduce an angle. So this angle right here, this angle, that angle. And I'm going to call this guy x. That's also x. So the cos of theta would basically be adjacent over, so adjacent is 5, and the radius is 10, right? So from there to there is 10. So 5 over 10. So very quickly you can figure out that theta is 60 degrees. So that means that sector is 120, since it's 60 on both sides. So its area would be 120 divided by the full, which is 360, times that 100 pi, which is the total from here. So that's basically going to be 100 over 3 pi, the area of that sector. Now the area of the shaded region, which is just the water, just this guy, that part, how do we get that? Area of shaded, or area of water, I guess. And don't get confused, we're not talking about volume yet, we're just talking about the area. Well, that would just be take the sector and then subtract from it that triangle. So subtract from it that triangle that sits on top of that. So the sector we just got was 100 over 3 pi. And then the area of the triangle will be 1/2 base times height. The base is x, so I got to figure out x. And the height is 5. Okay, well, let me figure out x over here. We're using Pythagoras. X squared plus 5 squared is 10 squared. Yeah, x squared plus 5 squared is 10 squared. So x, if you solve for this, would be 5 root 3. So I'll put the 5 root 3 there. And when you crunch out this will be 100 pi over 3 minus 25 root 3. Hold on. The base is not 5 root 3. The base is 2 times that because it's 2 of those. Okay, so it's a good thing I caught that. So this should actually be 10 root 3. So therefore that would be 25 root 3. Okay. All right, so good thing I caught that. Okay. So that's the first very important piece of the puzzle. Okay. Moving right along, that's pretty good. So let's move to the next part. The next part is we have to take that volume and then figure out what is the volume. This is just the area. So first we compare the volume, so volume of water over the total volume, which is 3,000 pi, and then we compare that to the areas, and the ratio would be the same. So the area of the total was this guy, 100 pi, and the area of just that segment is what we just did up here. So 100 pi over 3 minus 25 root 3. 100 pi over 3 over 20. Yeah. And then when you solve for this, you'll get the volume of water equal to 1,000 pi minus 750 root 3. Okay. But that's just this guy. What they're saying is later you add more water so that the depth increases from 5 to 10 plus 5 root 2. So right now it was 5, which is this guy. But they're going to add more water, so the water gets up higher to, I don't even know, somewhere around here. So let's do that again. We've got to do the same thing, but we have to now do it for a little bit different of a length. So let's draw another circle, and let's try to attempt to draw this. So this is sort of in the middle. And then what's the depth? The new depth is 10 plus 5 root 2. Okay, so 10 would basically mean that we are definitely that whole thing, because that's 10. And then another 5 root 2, which is approximately 7. So it's probably going to be somewhere up here. That's the new depth of the water. Okay. All right, I got it. So same kind of thing. I'm going to draw 2 lines here and 2 lines there. And then, let's see here. And then I think I have to do something similar, just like I did trigonometry last time. So it was 10 plus 5 root 2. So this top to bottom here is 5 root 2. This is a right angle, and I'll put my theta here, and that's 10. So this time the cos of this theta is 5 root 2 over 10. So that means theta is 45 degrees. So that means that sector, the sector that is, let me just draw it in here, this guy, this sector right here, that's going to be 90 is the total angle from there to there over 360 times the total area. Yeah, the total area, which we had calculated up here as 100 pi. Okay, so that's basically just 25 pi. And then now the unshaded guy, so the unshaded guy is this one here. That's what we don't want. We want everything else except that. So that unshaded, basically the part that's not water or represented by water, because all of the rest is water, that's going to be, let's see here, the 25 pi minus that triangle, so 1/2 base times height again. Yeah, so the height is 5 root 2, and then the base, do I have to do Pythagoras again? Yeah, I do. So if the base is y squared plus 5 root 2 squared is equal to 10 squared. So when you solve for this, you get y is equal to 5 root 2. So that means the base would be 2y, so that's 10 root 2. Yeah. Okay, so this will be 25 pi minus 25 times 2, which is 50. Okay, so that's the unshaded. Unshaded. So what we want is the volume of the water. So the volume of water, hold on here. Now, no, let me not call it volume, because that's going to make it confusing. We just want the area of the water of this guy. Yeah, calling it volume is confusing. Sorry about that. We just want all this stuff right here. That is basically the full area, which is 100 pi, minus this top unshaded. So minus the 25 pi minus 50. That's how you would do it. Yeah, I'm pretty sure about that. Okay, so, and that's 75 pi plus 50. Right. Okay, so now finally we can figure out the volume of the water. So now the volume of the water, this new volume, the volume here, is basically a ratio over the total volume, if the cylinder was full, over the ratios of the area. So the total area is 100 pi, and the volume, the area of this shape right here, we just figured out right there. So you put the 75 pi plus 50. Yeah. Yes, indeed. I think that's it. So then, that would mean that the volume of the water, after you added it and the height grew, you'd solve for this, and it would be, that would be 30 times that. So it would be 2250 pi plus 1500. Okay, finally. So now, finally, we have to figure out how much water was added. Well, we initially had this much volume, and now we have this much. So how much was added, we have to make a comparison. So we have to take one from the other. So we'd have to go 2250 pi plus 1500 minus that 1000 pi minus 750 root 3. That is how much water was added. So that would be, if I've done this properly, 1250 pi plus 1500 plus 750 root 3. Yeah. So this is how much volume of water is added, and they have saying that this is of the form A pi plus B plus C root P. So my A, B, C, and P looks to me like the A is 1250, the B is 1500, the C is 750, and the P is 3. And that completes number 10.